All right, so let's pick up with part 3. So we're going to work on number 8. So we're going to solve 2 sine squared x minus sine x minus 1 is equal to 0. So you can see that this is a little different from problems 1 through 7. And we're going to solve this in the interval. We're going to go from 0 to 2 pi, and then we're going to go from negative infinity to infinity. So when you look at this right here, hopefully you see that it kind of resembles a quadratic. And if that's the case, hopefully we can factor it, and that's exactly what we're going to wind up doing. So now you have an option. You can factor it just the way it is right now, including the sine function there if you recognize it. Or we can do a little substitution. And I can say that x is equal to sine x. So basically I'm going to replace all of the sine x's with an x. If I do that, that gives me 2x squared minus x minus 1 is equal to 0. Now this is more familiar to you looking at it as a quadratic and probably easier to factor. It's not a necessary step. You can factor it right from here if you recognize it. If not, you can do the substitution to do that. Well, when I factor this right here, this is going to become 2x plus 1 times x minus 1 is equal to 0. If you're wondering how I did the factoring part, you can look at one of my other videos on factoring quadratics. So now from here, I'm going to go ahead and replace, put back my sine x. So this would be 2 sine x plus 1 times sine x minus 1 is equal to 0. So you could have went from here to here in factoring and not have done this part. It's just totally up to you. It depends on what you recognize. Well, once you get to here, how do you solve by factoring? You take each factor and you set it equal to 0. So 2 sine x plus 1 equals 0, and then sine x minus 1 is equal to 0. So I'm going to solve these two separately. So I'm going to subtract the 1. So I get 2 sine x is equal to negative 1. Divide by 2. So I get sine x is equal to negative a half. Then on this side, I'm going to go ahead and add 1. So I get sine x is equal to 1. So now we have to look at both of these to get the solutions for these before we can answer any of these problems right here. So think about sine x is equal to negative 1/2. Where is that? Well, where is sine negative? So sine is negative in quadrants 3 and quadrants 4. So we're going to be here and here. So that's going to be our quadrant 3, and that's going to be our quadrant 4. Well, you could either identify based on the unit circle, because this order pair, this actually coordinate is a half, or negative a half, which is why it's negative in here. Or you could just do the inverse to both sides and get your reference angle. Either way, it's going to wind up being 30 degrees as your reference angle, which is from here to here and from here to here. Or if you identify it on the unit circle, you'll see that the y coordinate here is negative a half and the y coordinate here is negative a half. It doesn't make a difference. So this happens at 7 pi over 6, and it happens at 11 pi over 6. Whether you're using the reference angle, this would be 210, this is 330, or you're using the unit circle. Well, when is sine x equal to 1 over here? Remember, it is the y coordinate. The y coordinate that you're looking for it to be 1, which happens here. This is 0, 1, and that's at 90 degrees, which is pi over 2. So I have these three values that are solutions to this problem right here. So for A, I have x is equal to pi over 2, 7 pi over 6, and 11 pi over 6. And then for part B, which would be from negative infinity to infinity, all I need to do is list those three solutions and put on the period times n, so 2 pi n, 7 pi over 6 plus 2 pi n, and then 11 pi over 6 plus 2 pi n. So So this is for part A, from 0 to 2 pi, and then this was from negative infinity all the way to infinity. So let's look at another one that has to do with factoring. So I'm just going to flip this paper over here. So this is number 9. So we're going to solve 2 cosine squared x minus 3 cosine x plus 1 equals 0. And we're going to do that from 0 to 2 pi. And then we're going to do that from negative infinity to infinity, part B. Take a little sip of coffee here. My students who know me, of course, know I always drink coffee. All right, now I'm ready. So we're going to solve this. This looks like a quadratic again, so we're going to factor it. I'll go ahead and do the substitution and say that x is equal to cosine x. Then if I write this out, it's going to be 2x squared minus 3x plus 1 is equal to 0. And when I go ahead and factor that, I get 2x minus 1 times x minus 1 is equal to 0. Again, you can go back to one of my factoring videos on my YouTube channel if you need to look at that. And then we're going to replace the x with our cosine x to get back to our original problem. So 2 cosine x minus 1, and then cosine x minus 1 is equal to 0. So now we have to go ahead and solve each of those separately. So this would be 2 cosine x minus 1 is equal to 0, and then cosine x minus 1 is equal to 0. So I'm going to add 1. So 2 cosine x is equal to 1, divide by 2, and I get cosine x is equal to 1/2. And then over here, cosine x, I'll just rewrite it because I already started doing that. And then I get cosine x is equal to 1. So here, when is cosine positive? And you can see a lot of these numbers, the values are repeating because they're right on a unit circle. It's not always going to happen that way, as you'll see with some examples that are coming up. But hopefully you recognize, again, when is cosine equal to 1/2? It's positive here, and it's positive here. So that's going to be our quadrant 1, and that's going to be our quadrant 4. And then in quadrant 1, hopefully you know it's 60 degrees. So that's going to be 60 degrees. And that's 60 degrees as a reference angle. So here in quadrant 1, that's pi over 3. And in quadrant 4, 300 degrees, which is 5 pi over 3. And then we want to know when is cosine equal to, cosine x equal to 1. Well, cosine x equal to 1, that's the x value. This is 1 comma 0. Well, that's at 0 degrees, and if you go all the way around, it's at 2 pi. Well, if you look at the interval here, we're only going to 0, including 0, up to 2 pi, but we're not including the 2 pi. So for this right here, this is going to happen at x is equal to 0. So now we can go ahead and list, so for part A, x is equal to 0, pi over 3, and 5 pi over 3. And then for part B, x is equal to, so we have 0 plus the period times n, and then this pi over 3 plus 2 pi n, and then 5 pi over 3 plus 2 pi n. All right, so hopefully you can see another factoring problem, and hopefully that makes a little bit more sense. We're going to look at another one in problem number 10. So with this one, we're going to solve. So 2 sine squared x minus sine x is equal to 0. We're going to do that from 0 to 2 pi, and then we're going to go from negative infinity to infinity. Now when you're watching these videos, if we're doing problems that are similar, you can just pause the video, try the problem yourself, and then go back and watch and see if you got it correct or where the mistakes were. Until we get to the practice, you can do that. Now, if it's a brand new problem and you don't know, of course, go through it. But when you start looking familiar, then I would actually just pause the video and try it yourself to see if you can get it. So for this one here, I look and say, well, we can't really factor this because we don't have a trinomial. But that's not true because we have a common factor, and a common factor is factoring. So if I go ahead and say that x is equal to sine x, then this would be 2x squared minus x is equal to 0. Well, both of these have an x, so I can factor out an x and get 2x minus 1 equals 0. So that is factored. Then I can go ahead, put my sine x back in there, and I get 2 sine x minus 1 is equal to 0. So now both of these, I'm going to set them equal to 0. Your common factor, it has the variable in it, so you're going to set that equal to 0 as well. If it was just a number, like 3 times 2 sine x minus 1, you would just ignore it. But it has the variable here, so we're going to set that equal to 0. So this would be sine x is equal to 0, and then 2 sine x minus 1 is equal to 0. Well, this is already solved. This one I'm going to go ahead and add 1. So I get 2 sine x is equal to 1. Divide by 2. And there's that half again. So sine x is equal to a half. So when is sine x equal to 0? So that's when you want the y-coordinate to be 0. Well, here, this is 1, 0, and this is negative 1, 0. So that happens here at 0, and it happens here at pi. So this is at 0 and pi. And then here, sine x is equal to a half. Again, all students take calculus. So where is sine positive? It's positive in quadrant 1 and quadrant 2. You can do the inverse of this to get the angle. You can go to the unit circle. You can use the special right triangles. Again, you have all those options. This is going to be 30 degrees, which is pi over 6. And then from here to here, it's going to be 5 pi over 6. Remember, this would be your reference angle, which is 30, makes that 150, which is 5 pi over 6. So then our answer for A from 0 to 2 pi would be 0, pi over 6, 5 pi over 6, and pi. And then for part B, we just need to list all of those with the period n. So plus 2 pi n, pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, and then pi plus 2 pi n. All right. So we're going to look at number 11, and this is going to be a little different because these answers right here, they're not going to fall on the unit circle. They're not going to fall on the unit circle, so we're actually going to have to do the inverse, and we're going to have to round our answers. And you recall we've done that plenty of times with the previous sections working with the values of the trig functions. All right, so let's look at number 11. But we'll have to wait until part 4 in order to look at the next one.